Alright, so this video is going to discuss angles formed by intersecting segments within circles. And the first thing we want to talk about is the angles that are formed when chords intersect. So in this diagram here, we have chord BC and chord AD, and they intersect at point E. And we would like to know the measure of angle 1, right there. It turns out that the measure of angle 1 is equal to the average of the measure of arc AB and the measure of arc CD. In other words, you can find the measure of angle 1 by adding together arc AB and arc CD and then dividing by 2. Let's try it out with an example over here. So in this case, I have the measurements of arc DE and arc GF, and I want to know the measure of my missing angle right in the middle of that circle right there. So what I'm going to do is add 50 plus 100 and multiply by 1/2, or divide by 2. Multiplying by 1/2 is the same thing as dividing by 2. And that's going to be 75 degrees. So this angle is 75 degrees. Also, the one right across it is 75 degrees because those are vertical angles. So when chords intersect inside a circle, you can average the measures of their intercepted arcs to find the measurements of the angle that they form. Just add those arcs together and divide by 2. Now let's talk about when we have tangents and secants that intersect. So remember, a tangent is a line that intersects a circle at exactly one point, and a secant is a line that crosses through a circle, intersecting it at 2 points and continuing on the other sides. So in this case, when the tangent and the secant intersect, the measure of the angle formed is half the measure of the intercepted arc. That sounds familiar. That's very similar to the inscribed angle relationships. And here's how I would write that using a formula. So the measure of the angle I want here, the measure of angle XYZ, is going to equal half of the measure of arc XY. Let's use that for our example where we have an angle that measures 85 degrees. So the measure of this angle right here is 1/2 of the measure of this arc. Since I have the angle, I can substitute that into my equation, and that tells me that 85 degrees is 1/2 of the measure of that arc. So now I'm just going to multiply both sides by 2, and that tells me that 170 degrees is going to be the measure of arc XY. So the angle is half of its intercepted arc. So if I'm given the angle, I can multiply by 2 to get the arc. Here are 3 more relationships formed by tangents and secants. In the first case here, we have 2 secants that intersect outside of a circle, and they both cross through the circle at a couple of points. The formula tells me that the measure of angle ACE is equal to arc AE, that measure, minus the measure of arc BD divided by 2. So I like to call it big minus little divided by 2. Here's an example of that. So in this case, in the example we've been given, we have 100 for the measure of arc AE, and we have 20 for the measure of arc BD. So we can write that the measure of angle ACE is going to be 1/2 of 100 minus 20. So that's 1/2 of 80. That's 40 degrees. So the measure of this angle right here is 40 degrees. There's really a very similar relationship when 2 tangents intersect. So here we have 2 tangents. They touch the circle each at exactly 1 point. And this time, to find the measure of angle ABC, we're going to subtract the measure of arc ADC minus arc AC, and then we'll divide by 2. Once again, I like to think of this as big minus little divide by 2. So let's give it a shot here. So this time I know that my smaller arc AC, is equal to 60 degrees. So then how big would my larger arc be? How big would arc ADC be? What would that measurement be? Well, I know that if I add these 2 arcs together, they should equal 360 degrees. So 60 plus x equals 360 degrees. So x must be 300, right? So that means that my larger arc here, my major arc ADC, is equal to 300 degrees. Great, now I have all I need. So once again, we're going to do big minus little, divide by 2. Let's see, 300 minus 60 is 240, and I need to know what half of 240 is. That would be 120. So my angle measure here is going to be 120 degrees. And if you're following patterns, you'll notice that that relationship holds true when a secant and a tangent intersect as well. So here we have a secant intersecting a tangent, And our formula tells us that the measure of angle ACD is going to equal arc AD minus arc BD divided by 2. So again, big minus little divided by 2. And our third example illustrates this relationship. So in this case, we have 175 degrees minus 35 degrees, and we want half of that. We want to divide by 2. So 175 minus 35 is 140, and half of 140 is equal to 70 degrees. So that means our angle here is equal to 70 degrees.